Okay, welcome to lesson 3. Today is, I believe, system of linear equations. So if you'll zoom in on the corner, so I went ahead and made a list of everything we've been going over in orange, and I made a little cheat sheet up here on the dry erase board. So tomorrow when I email out the video to you, you can go back, pause it. I wouldn't do it today during class because we're going to be learning stuff and writing a lot of stuff down. But you can always pause it tomorrow and then kind of copy it if you don't have it. But this is most of the stuff in orange. So I'm going to go over it real quick just to show you what it means. The slope, most of this is in red. Delta y over delta x means the change in y over the change in x. So you just take a point, subtract the y's, subtract the x's, that's your slope. If you have a positive slope, remember it goes uphill. The line's going to go like this, like this. If your slope is negative, you'll go downhill, so it will go downhill. Parallel lines, they have the same slope, okay, if it's parallel lines. It means that whatever's in front of the x is the same, half and a half. Does not matter if the y-intercept is the same. They're still parallel as long as the slope is the same. If they're perpendicular, they'll have opposite reciprocals. So it doesn't matter what your y-intercept is, but your slope will be half and then -2. So half is perpendicular to -2. If slope is 0, that means you have 0 divided by any number. The line will be horizontal. If your slope is undefined, some number divided by 0, it will be up and down. A little cheat here is if you have anything on the test that says y equals 3, y equals -2, y equals any number, they're all going to be horizontal. Somewhere it's going to cross this way across the y-axis. Likewise, if it's x equals a number, it's always going to go up or down. Don't forget that your y equals mx plus b equation, the m is the slope, b is the y-intercept, the slope is also a rate, y-intercept is also a fixed amount. And this is some of today's notes we're going to write down for today, later. How can two lines cross? Or they can say, how many solutions can they have? Your answers for two lines, okay, line meaning straight lines. We're not talking about solutions for hyperbolas, circles, ellipses, and parabolas. We're talking about just lines. The options are 0, 1, or all, which is infinite. If they have nothing in common and no solutions, it means they're parallel, they never cross. If they have only one solution, it means the two lines intersect, they cross somehow. If all solutions are the same, they're infinite, it means the two lines are identical. Otherwise, infinite solutions. The word solution you're going to see a lot now when we look in the book. The solution to a system of equations means they have at least one point in common. So that's the target word. And like I said, tomorrow when I email this to you, you can freeze on that screen and copy it down if you don't already have it. But that should be the stuff that you already have. That's all the stuff I could find in orange from the last 2 weeks. Okay, so before we start the problems for today, I do want to go over something that is highly useful in the SAT, or kind of cheating. Not cheating, but it's sort of a cheat to get through something quickly in a problem. And it's going to be solving systems of equations by elimination, adding and subtracting equations. So let's write one down, for example. Let's write down -4x minus 2y equals -12. Positive 4x plus 8y equals -24. This will be yellow. So this question might be find the solution. Here's that word they use all the time. Find the solution to these two lines. Okay, so we're not going to graph these right now, but you could graph them both and draw them out, but we're not going to do that right now. That is something you'll do in algebra, but not so much for the SAT in this situation. Okay. So this one's been set up nicely for us. It's already set up. Both equations have x's, y's, and numbers. Okay. See, it set up x's first, then all the y's, then all the numbers. How many of you have done this?
I have.
And Kevin, Aaliyah?
I'm pretty sure I have.
Yeah, me too.
Okay. Okay, good. So this one's already kind of set up nice for us. We're going to add them. This one's already a negative 4x. This is a positive 4x. So we can just add straight down. And we're going to get, this will be 0. This will be 6y equals negative 36. Divide both sides by 6. Y equals negative 6. So number 1, we're going to write this out. Make one variable cancel out. In this case, we have a negative 4x and a 4x. So those are already done for us. So that's already done. Okay. Number 2, we're going to add and solve. Green. Number 3, substitute. Answer. So if y is negative 6, we'll just pick either one. It doesn't matter. I'm going to pick the one with the more positives in it because I like working with positive numbers. So I will choose the 4x. Oh, I should have showed that. That's okay. Four. It's positive. I'm sorry, the y is the negative 6. So wait, what did I just do wrong here? Hold on. Let me do it with the first equation. That's how I worked it here. And then I'll go back. I must have done something wrong. So let me try negative 4x. Oh, my brain. Times -2 times -6. And follow along with me. I'm doing this right? Plus 12.
Are you putting it in the first one or the second one?
I'm putting it in this first one now because I did something wrong in the second one. I got off somewhere. So I have -4x equals -24. This one works out much easier for me, so I'll just do this one.
It should be 6.
Yeah, x is 6. That is correct. I'll go back later and fix the other one. For now, substitute the answer. I'm going to, and this is also good for actually when you're taking a test. I noticed in the middle of it, because it doesn't matter which one you put the answer in, I noticed in the middle that something looked off, so I just stuck it back in the other equation. See, I started off with this one, did something wrong, noticed it, so I just went ahead and did this one. It's fine. That's what happens. Okay, let's do another one. I want to do at least one more normal before I throw some questions at you that involve this. So let's do x minus y equals 11. 2x plus y equals 19. Here again, the variable that will cancel out is the y, because it's already set up nice for us here. So if we just add these straight, we get 3x plus 0 equals 30. Divide both sides by 3. X equals 10. Let me go ahead and highlight some of this so we follow our path. Make the variable cancel out. That's this one. And then we add and solve. This time we got x. And now we substitute. Obviously, I'm going to put it in the first equation. It's much simpler. So I'm going to say 10 minus y equals 11. So I'm going to add y to both sides and subtract 11. So y is -1. And if you need to go back later, you can always pause the video to go back. I'll definitely be going back to see what I did wrong in the other problem, but not right now. Okay. Let's try one where you have to change something minor. Let's do -6x plus 6y equals 6. -6x plus 3y equals -12. I'm going to multiply my first equation, both sides, by -1. That way my x's will cancel out. That's the easiest thing to do is to just make this a positive 6x, and it will add with the -6x, and that will cancel out. So when I do this, I get, right, when I do this one, I get positive 6x, because -1 times -6x is a positive 6x, minus 6y equals -6. Okay, that's my new first equation.
Wait, but if the 6 is turned to -6, wouldn't it be -18?
No, I'm just multiplying them by -1. I'm changing this equation into this equation. So this equation is actually the same as this one.
Oh, okay. I thought we were doing the addition and subtraction. So yeah. All right.
Yep. So these are the same. I just changed the sign of one of them. That way when I add them, right? So let me make this a little bit more clear. So I have that new one, which is 6x minus 6y equals -6. I'm just going to rewrite this one. -6x plus 3y equals -12. And then see that now when I add those, these will cancel out.
Right.
Okay, so then here, I'm left with -3y equals -18. Divide both by -3, and y is 6. So let's go back here to pink. And what I was doing was making this variable cancel out, making it positive. And I found that y now I'm going to substitute it into the answer. So I have -6x plus 36 by using this first one. I'm going to, since this is my final part of this, I'm using my original equation to work it through. -6x plus 36 equals 6. So if I put my -36 over here, I'm left with -6x equals -30. Divide both by -6. And x equals +5. Now, I want to show you how they write these answers, because the way I'm going to have some of the homework for you guys to do, for y'all, is they write it, see up here how it's, in this one problem here, let me divide this up. Let's divide this page up so that it's a little clearer. There we go. Lost a lid. Okay. The way they write these answers is they take, because this is x and this is y, they actually write the answer like this. 6, -6. Okay, that's this answer. This answer is 10, -1. This answer is 5, 6. So it's a data point, okay? It's a point on a graph. The place where these two lines cross is in red, okay? And the reason for that is, let's not forget that this is always x, y, right? X comma Y. So the X answer is 6, the Y answer is -6. So it doesn't matter what order you solve it in, as long as when you write your answer or you choose an answer, that's the X and that's the Y. Okay. We're going to do one more option that you might see in your homework for practice on these, and that is here's a good one. Let's do 7x plus 2y equals 14, and negative 14x minus 4y equals negative 28. Okay. I'm going to do this out to the side so that we have plenty of space. So that first step was make one variable cancel out. So in this case, I'm going to choose the 7. Doesn't matter, but let's choose 7. So I'm going to multiply this first equation by 2 everywhere, 2 on both sides. Okay, not squared, but times 2. So this first equation is going to become 14x plus 4y equals 28. The bottom equation is negative 14x minus 4y equals negative 28. Okay? That's our given problem. And what do you notice about these two equations? What happens if I add them?
Cancel out to 0. Right.
Right. So what you need to be able to recognize is when you see two equations that look like this, what happens if I multiply this bottom equation by -1 on both sides?
And they would just add together, and it would become the same as the top equation.
Exactly. If I multiply this bottom one both by -1, so you're going to notice if it all goes to 0, that should trigger your brain. If you remember over here, the options we have for over here is you have an option of they never cross because they're parallel. They have one point, which is the first 3 examples we just did, or they share all answers, or it's an infinite solution because the lines are identical. So which answer would this be? For what do they have in common? What's their solution?
They're identical.
Yeah.
Or they're identical.
Yep. So all solutions. So it's just all. You're going to look for the word all. They may use the word infinite. They may use the same. Okay. Okay. I want to get to, okay. This you're going to have to pause later I'm going to set it here for now, but then you're going to have to pause and maybe tomorrow you'll look at the screen. Can everyone see all of these numbers and problems?
Yeah.
Yeah.
I want you to try all these at home over the week, and I put all the answers in red. So work to get your X's as the first answer and your Y's the second.
Should we write all these down right now?
No. Tomorrow when I send you the video, just pause it and copy them down. So notice on this last one, what do you have to do first before you do anything?
You have to make the equations match. I
Right.
guess have x, then y's, then equals a number.
Yes, exactly. Yeah, line them up. And this one too. If you line this one up too. Okay. Let's look at those tomorrow. Okay, so let's open the book to number 1.
Could you fill out that sheet again?
Yeah. You can look at it tomorrow when you look at the video. You can pause it. I promise. I promise. Okay, so look at page 37 in your book. Number 1. It says if the ordered pair x comma y is the solution to the system of equations above, what is the value of y? Okay. So what it's given us is, here's our two equations. X plus y equals 29. X plus 2y equals 12. And it wants to know what is y. Okay.
What's the page number again?
37. Page 37 in your SAT book. So if it says what is y, what would you try to cancel out? What do you,
X.
the x, right? Yeah, because you don't need the x. So if you don't need the x, let's cancel out the x's. Okay. So let's multiply a -1 times the bottom one. Let's do a -1 times this one right here. So we'll have x plus y equals 29. Negative x minus 2y equals -12. So those cancel out. We're left with negative y equals 17. You multiply both sides times a -1. You get y is negative 17. I'm not going to rewrite this stuff right here, but let's keep the same color code as we do them. So the variable that we canceled out were the x's. And we got to this answer, y equals -17. So 1 is A. Okay. Do y'all see how fast that one is if you know how to do your substitution pretty quick?
Yep.
Yes.
Okay. Let's look at number 2. The graph of a system of linear equations is shown above. If the ordered pair x comma y represents the solution to this system, what is the value of x minus y? So it sounds pretty complicated. It's a lot of information, but all they're really asking you is, so first of all, what's the solution? What are they asking for? The solution is what in the picture? This
The
is,
ordered pair.
it is, right, but in the, I'm trying to figure out how to, okay, so here's the picture, right? We have this picture, and they cross like this, right? So what they're asking for is, what is the solution? So the solution, as we talked about on the dry erase board over there for our notes today, the solution is where they cross. So where do they cross? What is the x, y coordinate of where they cross?
So then we also have to do x minus y. So it's basically just,
Well, wait, so, but before you do that, where do they cross? What's the point?
it'd be
Negative 3, negative 1.
No, it's +3, -1,
Oh, yes.
right?
Yep. It
Yeah.
goes 1, 2, 3, -1. Yep. 3, 1. And then label that's your X and that's your Y.
So it's 4 is the answer. D.
Yes. So X minus Y is 3 minus -1. Minus a negative is plus a positive. So 4 is your answer. That is correct. Okay. Let me pull up another one here. Okay. Let's look at number 3. Number 3. If 5b equals 6a plus 16 and 9a equals 7b minus 20, then what is the value of 3a minus 2b? First thing I'm going to do for number 3, if I'm looking at this, is I'm going to focus on this. What is 3a minus 2b? Now you have to kind of reverse engineer this problem, because if they're only trying to give you something you can do in 60 seconds, surely they don't want you to spend a lot of time. I mean, they could. If it's a difficult problem, they could want you to do it the complicated way, which is lining them up, you know, like this, like we've been doing, right? Line them up, subtract them, solve for each variable, then plug the variables into A and B. But let's hope that sometimes they're just going to give us an easy answer.
Well,
We're going to hope that. So let's see, they explain it really well too. So turn to page 41.
wouldn't you just do the subtraction thing we did earlier for the two first equations or addition thing we did, and then just input the values of the A and B to the
Yeah, so you can, and that will work if it's a hard problem, yes. But if it's an easy problem, so let's look back at the original problem, right? Let's line those up. So we have negatives. Sorry, we have 6a minus 5b equals -16, and then we have 9a minus 7b equals -20. So I went ahead and put these in order. Okay. Giving y'all time to write those down. Because I'm hoping there's, yes, we can solve it the complicated way, but if we're lucky, I'll show you what could happen. And this is what they're doing here. They're making it a quick solution on this one. Okay, so I happen to notice when I look at these, see how I have 3 and 2? If you look here at these whole numbers, 6 and 9, there's like a 3 in your head up here, you know, like there's a difference of 3. Here there's a difference of 2. Do you see that?
Yeah.
You have 3, 7, 5. So a lot of times they're going to make it look like this and make it simple where it should be a lot faster to do. So if I want to end up with a 3 and a 2, I'm just going to try this. I need to somehow get these to subtract to a positive 3. So if I multiply this first one by a -1, right, I end up with -6a plus 5b equals 16, right? I'm going to rewrite this other one so it looks nice. 9a minus 7b -20. So if I'm dealing with these two, and I add these two, I get 3a minus 2b equals -4. So the answer is -4. And they do this a lot in testing. And what they're hoping is that to catch, this is where they kind of separate students by point value, is you'll notice if you've done this and you think about it, you'll start to realize, look at every problem first as though it could be simple before you do it the hard way, because you could save a lot of time. Okay? The 9 and 6, once you line them both up, your brain should see, oh, wait a minute, I've got 6 and 9 and 5 and 7. That does make a 3 and a 2. So go ahead and just add them like they are. It'll take a lot longer if you do it the other way, because if you do it the other way, say you have a 6 and a 5 and a 9 and a 7. The only way to make these two cancel out the long method like we were doing before is you would have to choose something like 50. Let's say you choose 54 or something simple for this one. Let's say we chose 50. Okay, sorry, I'll make it simple. Let's choose 18. It's a lot smaller. If I were to choose 18 and trying to make these both 18, I can multiply this whole equation by 2. I can multiply this whole equation by -3. And then I would have 18 and -18, -18 and 18. So those would cancel the A's. So you're multiplying, you multiply through and solve. You can do the whole process, but the fastest way to do it is to just notice the other one. Let's see. I wanted to work one of those. I want to work, let's go to a new page. I want to go over one of those that might be like that, okay? For instance, let's do a problem such that -4x minus 2y equals 14, and -10x plus 7y equals -25. Okay. They may ask, find the ordered pair that represents the solution to this system. Okay, that's how they usually word these. Find the ordered pair that represents the solution to this system, to these two lines.
So wait, what is the ordered pair?
Ordered pair is a fancy way of saying x comma y.
Okay.
Yeah. Isn't that crazy? I know, they're trying to trick you. Ordered pair is x comma y.
Thank you.
That's some of those terms you definitely want to just not really worry about. That's just they try to throw these kind of words in there to trick you so that you get stuck on them. Solution, ordered pair. You're really just solving. You're just looking for a dot. This is a dot.
Okay.
It's a dot. Okay, it's a dot. It's a point. I know it's silly that they do that. Actually, before we solve this, it's very important to notice that we are talking right now about linear equations, as it says in the table of contents. Let's see. It's called systems of linear equations. So a linear equation, something to remember, that is a line. Okay, linear equation is a line. Because if you have two lines and they cross at some point, they can only cross at one point, or they can be the same line, they can be parallel, but they're all lines. So linear means they're lines. How do you know they're linear? Linear, you can always tell it's linear if you have no powers in your variables. This will come into effect later. Linear means no powers. No powers in variables. Okay, you can just have an x or just have a y, but you have no powers. You have no squareds, no cubes, no to the fourth power. Okay, see here we just have an x and a y and a number. Even on the dry erase board up here, even if you just have y equals 3 or x equals 5, there's no power. It's not x squared and it's not y squared. Okay, so they're straight lines. As we go through this through the semester, we'll start to add in some more things, such as if you have one of the variables squared but not the other one, most likely you'll have a parabola. If they're both squared, you'll have a circle. If they're both squared and they have different denominators, you can have an offset ellipse. If you have cubes, you have a split parabola. There's all different kinds of ways to recognize it, but the simplest one is what we're doing now, linear. They're all lines. They have no powers. So these are the easy ones. They have nothing. They're all straight lines. Okay, let's get back to this one. So I'm going to multiply the first one by -5 and the bottom one by 2. So let's get back here to our little cheat sheet here, right? Make one variable cancel out. We're doing that by multiplying the top by -5. That'll make that +20. 2 times -10 will be -20. So that's what we're going to make cancel out. So we're going to cancel out these. Okay. Let's go ahead and write that. So what we have is 20x plus 10y equals -70. That's from using a calculator. And -20x plus 14y equals -50. I multiplied the bottom one. Choose the pink. Those are the ones we're canceling out. This top one was when I used the 5, and this one's where I used the 2. Okay. And now we're going to add and solve. Those cancel out. We're left with 24y equals -120. Divide both by 24, and y equals -5. It's the first thing we found, so that's green. All right, add and solve right here. And I'm going to put it back in this first equation. So I'm going to take -4x plus 10 equals 14. I use this equation, and this +10 I got by doing -2 times -5. That's how I got my 10. I will put that here just to show you. This is where I was substituting. So -4x equals 4. Divide both by -4. x is -1. So what does the solution as an ordered pair look like?
-1, -5, so x, y.
Yep, that's right. Yeah. Right, so if they want it that way, that's your x and your y. Okay. Well, I'll put this up again at the end while we're finishing. I'll tell you what, I'm going to go ahead and turn off the recording, and then we'll talk some more.